Righto, this is a worked example to illustrate use of the normal distribution where we don't actually know the mean and the standard deviation. The random variable y has a normal distribution with mean mu and standard deviation sigma, and then we're given a piece of information here. But before I come back to that, let me just this is a bit of text I've included elsewhere with these problems. Generally speaking, problems requiring whether it's solving for mu or sigma, or whether that it's just unknown, you really are there to test our understanding of the sort of mapping between the standard normal distribution and one with values for the mean, which are not zero, and some standard deviation, which is not one. And really, what these tend to be testing is on our understanding of the use of the standard normal distribution. The problem now with the calculators the way they are is that we don't really need to use the standard normal deviation for most purposes, because we can just plug in the parameters into our calculator and it calculates stuff quite easily. What it won't necessarily be able to do, though, is work backwards from the area stroke probability back to the random variable values if we don't know the mean and standard deviation, and that's part of this problem, basically. Okay, so let's just have a look at this. It says this random variable has got probability that the random variable is greater than 17 is 0.4. And then it asks us to find the probability that the random variable is between the mean and 17. Okay, well, we've got this curve drawn on here. We've got the mean in the middle, mu, drawn on the standard deviations there. Actually, not quite got them in the right place. They should be at the point of inflection here, where this starts, the direction of the curve changes the other way. Not quite right, but near enough. And here's 17. Okay. I've shown it as being outside, if you like, sigma. We don't actually know that, but it won't actually matter for the purpose of the question. All right, so, and we've marked this 0.4 on here. So, because what we're saying is the probability that the random variable is greater than 17 is 0.4. That actually means, I've drawn it on as like an arrow like this, but it actually means that this area here is 0.4. The whole area under the curve being 1, of course, but this area here is 0.4. It's sometimes easier just to show it like this. So then it says probability, find the probability that the random variable is between mu and 17. So what we want is this red bit here, between mu and 17. We want this area under the curve between these two lines, denoted by the red arrows. Okay, so how's that work then? Well, we know that this area here is 0.4. It's told us that. We know that the area to the left of mu is going to be 0.5 because of the symmetry. So what's left over for this bit in the middle then? Well, it's basically, we've taken out 0.5 for this side, and we've taken out 0.4 here. All that's left here is 0.1. So that would be the answer to part A. Doesn't look it from the diagram, but the diagram doesn't have to be accurate. It's just giving us an indication of what we're trying to measure. And the second part is the probability the random variable falls between mu minus sigma and 17. Right, that seems a bit more tricky, doesn't it? Okay, so this time this is the area that we're looking for. So we're going to be excluding all this area that's above 17 and all this area that's below minus sigma. Right, well, we know this already. We just use this 0.4. That's that area there. But what is this area? Okay, so what this is saying essentially is what what's the probability of this random variable y falling below a value which is 1 standard deviation less than the mean? Right, so if we were to actually translate that into standard normal terms, that would be, we've got a mean of 0 and a standard deviation of 1. That would mean, what would be the probability of the random variable falling lower than -1? Okay. And we can find that out. So if we assume 0 and 1, we could go to our calculator and we can work out that the probability that the random variable is less than -1 is going to be 0.159. So that's what this area is here, 0.159. Now I've not actually used our little mapping equation, which is z equals x minus mu over sigma, but that's essentially what we have done. And so yeah, so this area here is 0.159. So what's left then for this area delimited by the sort of the green arrowed line there? We take off our 0.4, we take off our 0.159, and we're left with 0.441. So that would be the answer to part B. All right, so yeah, so it's a kind of quite a nice little example, and these are very likely to crop up, and say really it's testing your understanding about the standard normal distribution, and how it and the mapping between standard normal and the distribution that is under consideration. Good. All right. Well, let's hope that that went in, and I'll see you next time.